I'm Jesslyn Janisha of Grade 9 Frontline Millennium School. My project is Agrivoltacis in India. In India, agriculture is the main activity, but the problem is supplying electricity for irrigation. In India, thermal power plants are used for generating electricity, but this causes pollution and increases the carbon footprint. So using my model, I have made a solution to enhance the SDG goal number 7, clean and affordable energy for all. So in my project, I am using Agrivoltacis to provide clean energy. But what is Agrivoltacis? Agrivoltacis is the combination of agriculture and photovoltaics. But what is photovoltaics? Photovoltaics is the usage of solar panels for generating electricity by converting solar energy into electrical energy. So in my model, I have used solar panels for generating electricity as the power source, and I have used motor pump for irrigation. Now I'll explain my circuit. This is my circuit diagram. I have used 2 transistors for the AND logic gate. Logic gates help the computer to think based on a logic. If this happens, then I should do this. This is how the computer will think. In logic gates, transistors act as switches. Switches, we have 2 positions, on and off. On is represented by 1 and off is represented by 0. So in this model, the first transistor is for checking the water level in the tank. So if there is enough water in the tank, then the first transistor will show 1. Next, the second transistor, it would measure the moisture in the soil. If the soil is dry, then the switch would be 1. So if in both transistors the value is 1, then the electricity will pass through it because the circuit gets closed and the motor will start to work. But if either one transistor or both are in 0, then it will not work. So this is how my model works. Now I'll show a demo. I have 4 solar panels. One is for glowing these LEDs, which are used as lamps, and the remaining 3 will be for the motor. Now we don't have sunlight, so I have stored all the power from the solar panel in these rechargeable batteries. These batteries I have connected to my circuit, in which I have added the 2 transistors, and I have a moisture sensor. The sensor will be inside the field, checking if the soil is dry or it's moist. Here I have a motor, and here is the tank. So I have 2 wires which will be checking if the tank is full or not. Only if the tank is full, then the water will start to get pumped out. Now I will connect the circuit. As soon as I connect, the water will be coming out. If I dip the moisture sensor into the water, which means that the soil is moist, then the motor will stop working. Now since the moisture sensor is dry, the water is starting to come out. Now I will dip the sensor into the water, which means that the soil will become moist. Now the water has stopped coming. If I take the sensor out of the water, the motor will get on. So using this, we can use this in many fields in India, and instead of using electricity produced from thermal power plants, we can use solar power plants. How is this model different from the existing ones? Well, I have some more enhancements which I'll be doing in the future. So these solar panels, when in the noon time, they'll be straight, which means that when the sun is on top, the light will be received fully. In the morning or in the evening, the sun will be in the slanting position. So I'll use a stepper motor to slant the solar panels, which means that the sunlight will be fully received throughout the day. This is my future enhancement, which does not exist now. Thank you.